Hello class, Ryan here, and for this tutorial we're going to work through exercise 10-8 from your textbook. It says, given the two objects shown below, draw a front and side view of each and assign a tolerance, actually assign a number of different tolerances as listed here. So I have the two base shapes started. These are millimeters, so I'm using my ACAD isometric template, and I've added a couple center lines, and just so you're aware, those center lines had to be around 0.75 or 0.5 for their line type scale to show up. And I might change the color of those so I don't confuse them with an object line. That being said, I'm not quite done. I have to add a chamfer here. So this shape is 30 by 30 right now. It's a rectangle. So I'm going to type in chamfer and hit the down arrow and go to distance and hit enter. And it says it's a chamfer of 3 and 3, which would make a 45-degree angle. Now I can go ahead and finish adding that bevel and then the line command to fill in across the face. So that completes that upper shape. This lower is actually a sectional view of a plate. So this is, some sort of a stud assembly that will slide down into this plate with a hole. So this would marry up with the other. So since it's a sectional view, I need to shade to show the material on either side of the hole. You know how to do that with the hatch command. And go down to your settings so you can see the whole hatch settings. We'll do predefined ANSI 131. We'll start off with a scale of 1, which looks pretty good. And there we have it hatched. So our base drawings are correct. Now if you look here, I've already drawn the top view of each. We'll call these both front view and front sectional view. So here's the top view, and actually we will do an offset of 3 so we can see that actual shaft, the edge of the shaft. And then here we have a view of this washer, if you will, with the hole bored through it. Now that I have all of this drawn, it's time to add dimensions and then tolerances. They give us dimensions and they say what they need to be, so kind of bear with me as I walk through my dimensions as we've done before. Edge to center. And I don't like how small that is, so I'm going to go to ISO 25. So I'm going to do dim style and modify that ISO 25. And I'm going to change the fit to an overall scale of 2. It's going to double the size of those, and we'll see if they look a little bit more legible now with these particular pieces. They do. So it's okay to play around with that until you get the look that you want for your scale. So we've got those. Actually, I don't know why I'm dimensioning here. We can dimension just like the book did on this face, just like this. And do a continuing dimension for the second half. And then we need a new dimension for the edge, just like so. They show a dimension. I use the spacebar to repeat that command here. Now instead of putting it there, I should do dim continue and just continue that last dimension. That way our dimensions are clean in a row like this. And that's all that they want for that particular piece. Now for this next piece, I can repeat that dim continue and just bring it all the way down like so, and then simply use the erase command to get rid of that. And then they want us to do along the bottom to the center 40, and then dim continue, dim cont if you're typing it in, just like so. One more dimension call out is for that bevel, and we can do that with a Q leader. So they want us to point at that and come off the side just like so. And you notice the leaders are scaled correctly to match our dimensions because we changed our dimension style. And our text should read 3 by 45. And for the degree symbol, it's percent. C, I believe. Oh, I had it backward. It's percent D. There we go. So we have all the dimensions that they list in the textbook. Now we have to add a tolerance, and it appears that they are all plus or minus 0.5. So again, I can go back to my dim style. Instead of manually changing each dimension, since they all have the same tolerance, I can modify that style and go to tolerances, make it symmetrical, and I believe it's just 0.5. And we don't want to, I think they are suppressed. We'll leave it alone, see how that looks. Oh, we do have an issue here. So you'll see we have a comma showing up. So if I go back to my dim style, modify, and go to my units, I'm going to change that comma to a period. That's better. Now here, if you have dimensions that overlap, just highlight the offender and use the grip point to drag it off the other way. We want this to line up still. And we can even drag it. Sometimes they let you drag them out, but this particular style has got it locked in, but that's sufficient for me. So I believe we have all of our tolerances correct as to what the textbook was asking for. Our linear dimensions are tolerance plus or minus 0.5. Now we have some odd feature and perpendicular and parallel dimensions to add. So what I'm going to do is type in tolerance, and that'll bring up this geometric tolerance menu. So I'm going to start here on the shaft, and they want us to make sure it is straight within 0.2 of the maximum material condition. So the symbol should be our straight symbol. We want the diameter because it's circular. Our value is 0.2. And if you just click in this box, you can pick maximum material conditions. We want that. They also want us to locate it within, the actual diameter of the shaft needs to be plus or minus 0.4. So if I just do the diameter symbol, I can do percent, I think it's P, bear with me here, 0.4. And this should give us, there I've got a live text window that's kind of hovering with me now. I'm going to plop it right there. So there we have our straightness tolerance, 0.2 of maximum material condition, and then our diameter of the circle needs to be within plus or minus 0.4. And I probably should plug in the actual diameter. So if I double click, oh, I thought it would let me edit those individual features again. When in doubt, you can always click and right click to see what options we have. There it is, tolerance edit. And that gets us back in here. So I should have put 30 in there, so we know it's a diameter of 30 plus or minus 0.4. So I think that's about what I want. Now I'm going to take and borrow with a copy this leader and just copy it straight up, and then use the grip point to go to the midpoint, and then I'm going to move this whole block from end to end so it lines up neatly. So I believe that's all that I need to define tolerance wise. They're asking us to assign the plus or minus 0.5 to all linear dimensions, a feature tolerance of 0.4 to the shaft, which is here, and a straightness tolerance of 0.2 to the shaft as well, the center line at MMC. So I believe we've done that with what we have listed. Now we'll move on to the plate, and the plate says tolerance the hole, so it'll accept the shaft with a minimum clearance of 0.1 and a feature tolerance of 0.2 and a perpendicularity tolerance of 0.05 to the center line at MMC. All right, so let's do the tolerance again, and we'll kind of work through this. So we need the perpendicularity, which is this symbol here, and we don't have a circle this time because we're just saying the hole is perpendicular. So I'm just going to do 0.05 and give me a second here. Instead of plugging in one of those, I would like a different datum. I think I can plug it in over here. I'm going to do a reference plane. We're going to reference a datum that I'm going to add later. So we'll see how that comes out, what I have written here. So that would be for perpendicularity, that first tolerance. The second one is going to be to make sure that the shaft will fit the hole. So I've done the math, and I believe 30.6 is the correct number for the diameter of that hole, but we're going to make it percent P, so it's plus or minus 0.2, and that should give me what I'm after. So let's see what this ends up looking like. We can probably just place it right here. So perpendicularity, 0.5 for A, that's right, and then a diameter 30.6 plus or minus 0.2. I think I like that. Let's again copy this leader down, like so. We'll point here at the hole, and then move the works up here. You're probably wondering, what's this A all about? Bear with me, I copied instead of moved. Well, that A is a reference plane. You probably read about it in your textbook. So what we can do is I can do, let me do it this way. I'm going to do tolerance again, and I can just plug in a datum identifier, A, and that just gives me a letter like that, which is kind of nice in a box, all in one unit. Now if I mirror this leader over, just like that, I can move A so it's right on it. And then I'm going to mess around a little bit. I'm going to drag this guy over and then drag it over so it's pointing almost straight down if I can. This isn't my better mouse, so it's not as accurate with these fine movements. I'm going to move it up just a little bit. Now if I highlight that leader, I can go in and change the arrow from a architectural arrow to a filled datum triangle, just like that. And if you can't get it quite square like I can't, don't be afraid to take a line up, just a construction line. Now you can pick your leader and drag it over so it bumps up against the side, and then we're perfectly square. So what I've done is I've said that this hole, which I'm going to actually take that all the way down into here, that hole needs to be within 0.05 perpendicular of A, and A is the reference plane that we've called out here, which is the flat top of the shape. So looking back at the question, I believe we've covered it all. We've done the top view of each. We've added the linear dimensions, and then we've added the feature tolerances and whatnot as well. So this is what I would be expecting from exercise 10-8. Do a save as. EX10-8, save, and bear in mind the whole intent here is for you to kind of get used to adding tolerances. I understand that there may be a few different ways to calculate what I've done here with the diameter of this hole, but just make sure you can add tolerances as I've done here and you'll be in good shape. Thank you.